Hi, I'm Hein, and today I'm gonna talk about doping. In doping, there are two types. First thing is diffusion, and second thing is ion implantation. Mm, at first, I will talk about the diffusion. Diffusion is the process which is using the principle of the diffusion of dopant. First of all, you have to spread the pre-deposition layer, which gives the dopant to into the substrate on the and after pre-deposition you have to give some energy like summer, so the dopants are diffused in the substrate. uh, in this process we have to know the concentration of the dopant along the depths is different because it used the diffusion, and the diffusion is independent to the dependent on the depths. So uh, we can get the deposition profile like more less dopant in the bottom side and more higher dopant, more dopant in the surface. In this process, we have to consider the summer body problem. The summer body means the total energy which is transferred in the vapor during the process. So, you the diffusion process use the summer, so we always have to consider the problem. And uh, also we use the annealing when we give some energy, the summer energy in the vapor. In annealing, there are two types: the furnace annealing and rapid summer process (RTP). Nowadays, most cases use the RTP because it the temperature goes up highly, and so we can lessen the time, so it leads to the summer body problem. So the total energy are decreased when we apply some when we makes it hot more faster. mm, the second method of doping is ion implantation. Ion implantation is using the ion which cools to the silicon vapor. For example, um, we can use the ion beam which is made with the plasma or some kind of filament. So with the ion source, we can uh, we can make we can choose one type of source in the many kinds of materials are mixed in the ion source with mass spectrometer. With mass spectrometer, we can filter the ion which we want to use, and then we spread out the ion beams in large space with the scanning system. In ion implantation, we have to know some mechanisms which stops the ion. Uh, the first mechanism is nuclear stopping. Nuclear stopping, it means the ion collides with the silicon lattice atom, the silicon nuclei of lattice atom. So in this process, the ion break down surroundings and transport the energy, so it leads to the damage of the substrate. And second method is using electronic stopping. Electronic stopping is the process when we ion past the atomic lattice, there are some electrons, so because of this we can make an electric field, and the electric field pull the ion to the opposite sides, so ion lose the velocity. This process is of course when the ion have very high energy, so it occurs when the first time when we implant the ion, and the nuclear stopping occurs when after the ion losing some energy, so the velocity of the ion becomes more slow. So the first time when we implant the ion to the surface damage are small and neglectable, but as some times go and the ion lose some energy, it collides with the silicon atom layer lattice and damage surroundings. When we use the ion implantation, we have to consider the mathematical model of ion implantation, because when we implant some ions in some space, the concentration of the ion is spread like a Gaussian distribution. So when we have to make a selective implantation, because of the Gaussian distribution, under the masking, we can find some ions which is implanted. So to make a good doping, we have to make that this side of dopants are more less than less than 10 times 1/10 than the body doping. Like this, the ion implantation in ion implantation process, the ion concentration have the Gaussian distribution. We can use this principle when we make a uniform profile with multiple doping. When we make a ion implantation, we have to consider the shadowing effect when we tilt the wafer to avoid the channeling effect. So when we make a process, we have to make a best condition which lessen the shadowing area. Nowadays, the many semiconductor devices doesn't dope a lot in the channel because it is very hard to conjure the less amount of dopant in the channel, and the this oh, I'm sorry, my recording was stopped because I don't have enough storage memory. And so all the difference of the concentration doping concentration in the channel are leads to the device problem, like difference of VT. So nowadays, uh, we don't dope a lot in the channel to avoid the random dopant fluctuation. Mm, from now, I introduced about doping and some method of dopings like diffusion and ion implantation. Thank you for listening.